Okay, here we go. Part 2, or as Mr. Chen likes to say, part 2. Number 13, properties of parallelograms. The opposite sides of parallelograms are equal. So after you label your sides, what you should do is set up an equation where this is equal to this. What Mrs. Pearson has done right here. Solve that equation. X equals 2. Now here you must make sure that you get the correct answer. Answer the question. Do they want X or do they want you to substitute in to find a segment? It looks like they want you to substitute in to find SV. So make sure you substitute in right here. X plus 3. 2 plus 3 to get your final answer.
Okay, for number 14, the key thing is that parallel means same slope. Really important that you understand that. In order to solve this problem, you need to take the original equation and you need to get y by itself. When you get y by itself, the slope is 5/2. So the answer that you get needs to also have a slope of 5/2. The way that I personally did it is I got y by itself each time. I skipped a couple of steps. Here I added 2 to both sides, and then I divided by 5 and saw right away that this was not 5/2. In the same process, you probably could get rid of choice 2 at the same without doing the work, just because if you have 5 on next to the y, you're going to divide by 5, which is not what you're looking for. In that same process, you should find that choice 3 gives you a slope of 5/2. Choice 4 does not give you a slope of 5/2 because of that negative there. So choice 3 is the correct answer. Make sure you have the notes for all of these, including the parallelogram characteristics. Going on to the next problem, number 15.
All right, so this, I like to find the vertex of this angle, and it's inside the circle. And when the vertex is inside the circle, I know the formula is the angle equals, I like to write it a little bit differently. I like to write 1/2 the major arc plus the minor arc, just slightly different than what Mrs. Pearson has here. Both going to give you the same answer. This is what we would consider our major arc because it's bigger in relationship to this one, which is going to be the minor arc. So substitute in major here plus your minor, divide by 2, and that will equal our angle CEA. Add those together, divide by 2, our angle should equal 61.
For number 16, this should be, I shouldn't even have to discuss this one. Anytime you have a right triangle, the only 2 choices that you have are trig or Pythagorean theorem. When you're looking for the third side of this right triangle, Pythagorean theorem automatically comes into play. Pretty imperative in your calculator that you use the parentheses though. When you use the parentheses and solve, please make sure that you're undoing a square to find the square root. The answer is choice 1.
And if, like Mrs. Pearson said, imperative, very, very important that you use these parentheses. If you do not use parentheses, it will not give you the correct values. Okay, next question. Done distance formula a lot. This is the distance formula that I like to use right here. The square root of the change in x squared plus the change in y squared. And as you know, I also like to use my fingers. Mr. Pearson has them bracketed out. So the change between a -3 and a 1 is 4. And the change between your y values from a 2 to a 0 is 2. substitute those values in, change in x, change in y, and then break this apart into a perfect square and a non-perfect square. And the square root of 4, remember what I like to do? Snap the fingers, magic happens, radical goes away, ends up with 2 radical 5.
The way around the distance formula, don't forget, is Pythagorean theorem, which is this process right here. You could use a scrap graph, which would be in the back of your regions. It wouldn't be graded, but you could do Pythagorean theorem. Number 18, very similar to the one that we just did pertaining to parallel, only this one says perpendicular. Please remember that perpendicular means negative reciprocal slopes, opposite signs, and flipped fractions.
Take the time in the questions, like Mrs. Pearson and I do, to highlight these vocabulary words.
So what I did is I started out with the original equation. Y was all by itself. The original slope is -3. So the perpendicular slope, instead of a negative, it's going to be a positive. And instead of 3/1, it's going to be 1/3. In this particular case, there's only 2 choices that could have a slope of 1/3. And that's either choice 3 or 4. So now you're down to a 50% chance of getting it right. And what ends up happening when you take and you substitute in, you find that choice 4 is the correct answer. Read those problems carefully, please.
This one, not a lot of work, complete geometry knowledge, and what we're looking for here is your recognition of vertical angles and your recognition of some alternate interior angles. And since we know that the lines are parallel, we know alternate interior angles are equal. If we have 2 angles that are congruent to 2 corresponding angles in these 2 triangles, we know that they are similar by angle.
Usually when you see these questions, if you're needing to prove 2 angles are congruent, 2 triangles are similar, and it's multiple choice, you are going to use angle similarity. So this problem is the opposite of number 10. Number 10, we were given some sort of center, and we were given a radius, and we needed to recognize that you take the opposite of the x value and the opposite of the y value, and you square the radius. So here it's just the same type of thing, only written backwards. Instead of starting with a point and the radius, we're starting with the equation. So the center has the opposite of -2 for x, and the opposite of +4 for y. So the center has to be 2, -4, which means you can use choice 1 or choice 2. And then the radius is the square root of the number that's left over, because it's the backwards version of that. The square root of 4 is 2. The radius of 2, you just count the boxes. So your answer is choice 2.
All right, anybody in my class knows that I'm up here pointing to the remote interior angles. So start by labeling the diagram and thinking exterior angle theorem. And the exterior angle theorem is the exterior angle is equal to this angle plus this angle. So if I add these 2 angles together, I am going to get 5x plus 14 equals the exterior angle. Now it's just a matter of your algebra kicking in. Subtract 5x, subtract 2, so x equals 12. Again, be very careful with these questions. Make sure they're asking you for x or to substitute in to find something. In this case, they're asking you just simply for x, so we are done.
Okay, this problem for number 22 goes along with what we've been spending so much time on with similar triangles. Similar triangles, just a refresher, please write this down. All corresponding angles are equal, and all corresponding sides are proportional. Really important. If we know the sides are proportional in a proportion of 3 for AB to 2 for DE, and yes, I know that my triangles are not drawn to scale. That's okay. Remember, I just sketched these two triangles first, and then I just fill in the numbers. If this ratio is 3 to 2, then so is this ratio, and so is this ratio. Also, the perimeters, because perimeters are only two-dimensional, those also have the same ratio. So BC to EF has a 3 to 2, and the perimeters also have a 3 to 2. Please remember that area is two-dimensional. Sorry, area is two-dimensional, which means that in order to find the side proportions or the proportion of the area, 2 dimensions means you square it, and you get 9/4. Angles are not unequal, so that one does not work.
All right, the next one, I don't think we've talked about this yet, but the exterior angles of any polygon have to add up to 360. The exterior angles sum 360. So the first thing that Mrs. Pearson did was find this exterior angle right here, which was 40. Now, what I would do is do something just simple on my calculator. 360 minus 40 minus 60 minus 84 minus 68 to come up with this missing exterior angle. Should be 108.
24, it's kind of a strange problem, I'll give you that. It says, through a given point on a plane, remember a plane is just a flat surface, it's like a piece of paper, and a point on that is if you draw the point. How many lines can be drawn perpendicular to the plane really means that you have a line that's not on that piece of paper, but rather coming straight through that piece of paper to create a 90-degree angle. So you kind of have to think of this as a pen sticking up through a flat piece of paper. There's only one line that is available to be perpendicular. Number 25, we've already discussed the negative reciprocal. Just copy this down, take a moment, make sure you understand how to get the perpendicular slope. Keywords for composition. When you have this dot right here, it means that you need to do this first. When you do a reflection over the line y equals x, it's really easier to use the rule, and you're also going to want to draw a scrap graph. I would use the scrap graph in the back of the test. You can turn your paper for a rotation of 90 degrees, or you can remember the rule. You graph the point 4, 2, which is right here. If you graph the line y equals x, that means 0, 0, 1, 1, 2, 2, 3, 3. That point is reflected. Much easier to use this rule. If you start out with x, y, you need to switch the order of those. So you plot the point 2, 4. You want to turn the paper counterclockwise. Unless it specifies you're always turning counterclockwise. If you turn that 90 degrees, the new point becomes -4, +2. Practice that on a scrap graph.
Okay, I only have about 40 seconds. Start with your volume, pi r squared h. Simple substitution, but make sure you're using the radius and not the given diameter here. The height, and this was the answer. Did not have to multiply that out times pi. Now, just want to mention, back in number 26, Mrs. Pearson did. Easy to remember this rule, y equals x. Just switch the x and y coordinates. And when you're rotating, make sure a positive rotation is going counterclockwise.